Alright guys, let's take a look at the homework. For number 17, we have a girl exerting a force of 36 newtons. So let's draw out a free body diagram for this situation. We have the girl pulling the sled to the right. We have the force of friction now to the left. This is the first time that we've really started to see friction. We have the force of gravity down, and we have the normal force up. The problem also says that we're moving at constant speed. Well, what does that mean? Constant speed means no acceleration. So if we have no acceleration, then the sum of the forces is going to equal 0. So in the sideways direction, or in the x direction, 36 to the right minus the force of friction to the left has to equal 0. Or in other words, 36 is going to equal the force of friction. So we know that the force of friction is equal to mu times the normal force. If you do not yet have that equation, take a look at the previous page or the example problem above. The force of friction is equal to mu, which is a Greek letter, which stands for the coefficient of friction, which is a product of the surface, and the normal force, which you're already familiar with, which is commonly equal to the force of gravity. Okay, so anyway, let's plug in some numbers here. We don't know what mu is, but we know what the normal force is. It's given in the problem. It says we have a 52 Newton sled, that's the weight of the sled, and the weight is equal to the normal force. Now we can solve for mu, and we get 0.69. Mu is always going to be a number between 0 and 1. It does not have units. It's simply an expression of how much friction two surfaces provide when in contact. In the next problem, we're moving a sofa. So it's important to know that at the exact moment that the sofa begins to move, the force that you are applying is going to be equal to the force of static friction. Static friction is the friction between a non-moving object. So if you push a box across the floor, the moment that the box begins to move, the force that you are applying to the box is equal to the force of static friction. So now we can set this up mathematically. The force applied, 102, needs to equal the force of friction. We know that the force of friction is equal to mu times the normal force. The normal force is also the force of gravity, or mass times 9.8. So knowing the mass and knowing 9.8, we can solve for mu. I want you to take a look at how I set that up. We know that the normal force is equal to mu mg, where g is 9.8. So sometimes it's more useful to just write the force of friction as mu times the normal force, and sometimes it's more useful to write it as mu mg. But it's essentially the same thing. Again, we see that our answer, the coefficient of friction, does not have units. Here we are dragging a box at constant velocity. Oh, excuse me, we're not dragging it. Let me pause for a second and reread the question. We are, oh yes we are. Oh no, we're getting it to start moving. Remember, at the moment that you start a box to move, the force applied is equal to the force of friction. So the force applied is equal to mu times the normal force. In this case, we know the normal force. It's given in the problem as 134. Remember that the normal force is the same as the force of gravity. So then we can simply solve for the applied force. Let's take a look at number 20. We have the same sled as in the previous problem. And it says we're at constant speed. Remember what that means. Constant speed means no acceleration, so the sum of the forces are equal to 0. So that means that the force applied needs to equal the force of friction. So if you take a look at your free body diagram, you have an applied force in one direction, you have friction in the opposite direction, you also have the normal force and the force of gravity, and if there's no acceleration, everything is equal and opposite. So the applied force must equal the force of friction. So we can set this up. We know the equation for the force of friction, mu times the normal force. We know mu, we know the normal force. Be careful here. You got to add the normal force of the person plus the normal force of the sled. And then when you multiply it out, you can find the applied force, 84 newtons. I hope that this was helpful.